Convex mirrors is also called diverging mirrors. These are often used in vehicles and hallways. But why do they always make images smaller? Today, I'll explain step by step how to draw ray diagrams for convex mirrors so you can understand them easily. Here are the important parts of a convex mirror. Number 1. Principal axis. This is the reference line passing through the mirror's pole. Number 2. The optical center. This is the center of the mirror surface. Number 3. Focus. This is located behind the mirror since convex mirrors spread rays outward. Number 4. Center of curvature. This is also behind the mirror. To find the image, we just need two rays. Ray number 1. A ray parallel to the principal axis reflects outward as if it came from the focal point behind the mirror. Ray number 2. A ray directed toward the focus reflects back parallel to the axis. Where the reflected rays appear to meet behind the mirror, that's where the image is formed. No matter where you place the object in front of a convex mirror, the image has the same characteristics. It is always virtual, upright, and diminished, meaning smaller than the object. That's why convex mirrors are perfect for giving drivers a wider field of view even if objects appear smaller. Convex mirrors are commonly used as side view mirrors in cars, in CCTV security mirrors, and even in road safety mirrors at blind turns because they show a larger area. So to summarize, convex mirrors always form an image that is virtual, upright, and diminished. No exceptions. If you found this video helpful, please hit like, subscribe, and share this with your classmates so they can master physics too.